Hello everyone, welcome back to the video. Today we'll talk about the air refrigeration system of type 5. First of all, I'd like to highlight that some of the students have dropped their weapons when it comes to RSE. So let me continue my poem. तू बोर का पहला तारा है, परिवर्तन का एक नारा है, ये अंधेरा बस कुछ पल का है, फिर सब कुछ तुम्हारा है. I hope you guys are damn motivated right now. Now let's continue with the topic. Reduced ambient air cooling system. All the processes remain same till this point. There is nothing new. The difference is now the rammed air is passed through a cooling turbine. Now, what happens in the cooling turbine? Cooling turbine is nothing but a turbine which lets the cooling air flow through it and which expands the cooled air. A cooling turbine is a turbine which expands the already cooled air. Hence it is named cooling turbine. A rammed air is already cooled. Rammed air is not hot in temperature, it is just high in pressure. So rammed air which is already cool is and high in pressure comes here, it flows through the turbine, and obviously in a turbine a pressurized gas always expands. So here it expands, cools down further and passes in the shell of the heat exchanger, this one, and the first compressed gas from MC1 from main compressor flows from the tube marked black arrow. So the heat from the black arrow tube rejects, the heat is rejected from the tube air to the shell air, and then as this air passes through here, it rotates the fan. So you would ask, why do we need this fan? A fan creates a vortex. A fan, obviously, if we look like simply above on the ceiling, on us the air is pushed here, but over the fan the air is pulled from here. If we could imagine that if the fan is like this and this is the ceiling, then we get air over us, but over the fan ke upar air is being pulled towards it. So we need a fan to pull the air towards it. So it is a very resultant effect that as this turbine rotates, it rotates this shaft, and hence it rotates this fan, and as this fan rotates, it pulls the air. So it is a very resultant effect that it cohesively works the whole system. And now we can see that as the black arrowed air from the compressor 1 cools down because of the rammed air passed through it, it is simply passed to the air to the cabin turbine. So it is passed through the secondary cooling turbine. Now here this air being as it is cooled in the heat exchanger, but it is still on the same pressure after as it, like we'd say that uska pressure is same as its outlet from the MC1. Pressure either is same because we assume that there is no pressure loss in the heat exchanger. So when it goes to the secondary cooling turbine, again cooling turbine उसका एक ही काम है to expand the air. So it will expand the air, but a shaft is connected to the cooling turbine 2. This shaft is connected to cooling turbine 1. Now ये जो shaft है that is connected to secondary cooling turbine. So the turbine rotates and that air is simply sent to the cabin. This process is complete, but the speed of the air for a high speed airplane is so fast that it is very unuseful, or we could say that it is very inefficient for the whole system. अगर air is very fast, तो जो heat exchange होना चाहिए between ये वाली air and the black arrowed air वो अच्छे से नहीं होगा. We need to maintain a certain time of contact between the shell and the air inside the tube. So उसके लिए हमने एक mechanism लगाया, that is the reduction mechanism. रिडक्शन मैकेनिज्म से क्या होगा कि जो रिडक्शन गियर्स है, दीज आर द रिडक्शन गियर्स, ये जो गियर है दैट विल मेंटेन द स्पीड ऑफ दिस फैन. सो अगर ये फैन धीमे घूमेगा तो उसके अंदर हवा उतनी ही धीमे आएगी. अगर ये बहुत फास्ट घूमेगा तो ये वाली हवा बहुत फास्ट सर्कुलेट होगी, इधर से इधर, फ्रॉम ईयर टू ईयर, ये बहुत फास्ट सर्कुलेट होगी. अगर ये फैन धीमे घूमेगा तो हवा भी इधर से बहुत धीमे सर्कुलेट होगी. सो if the air circulates very slow, then it is good that there is more contact time between the red arrowed air and the black arrowed air. I mean the arrows, black arrow and the red arrow. Hence, we use a reduction mechanism to ensure that there is good amount of contact in the heat exchanger and to ensure the overall efficiency into the system. So इधर देख सकते हैं कि फर्स्ट टर्बाइन घूमता है और ये फैन घूमता है, पर ये फैन पे सेकेंड टर्बाइन का भी असर है बिकॉज ये दो गियर्स को कपल कर दिया है. दीज आर बेवल गियर्स, सो इनको कपल कर दिया है. सो इसका स्पीड और इसका स्पीड ऑप्टिमाइज होके ही ये फैन घूमेगा. सो ये बहुत फास्ट भी नहीं घूमेगा, बहुत स्लो भी नहीं घूमेगा, ये घूमेगा एज पर द रिक्वायरमेंट्स. सो दिस वॉज द होल लॉजिक ऑफ दिस फैन ईयर एंड द होल रिडक्शन मैकेनिज्म ईयर. अगर हवा बहुत फास्ट फ्लो हो रही है तो देर आर सम ड्रॉबैक्स दैट द सिस्टम ओवरलोड्स द, इट मेक्स अ लॉट ऑफ नॉइजेस. फर्स्ट ऑफ ऑल, अगर हवा बहुत ज़्यादा घूमेगी और बहुत स्पीड में घूमेगी तो बहुत आवाज़ करेगी. एंड अगेन, अगर बहुत फोर्स से हवा इधर निकली तो इट विल बी अनकंफर्टेबल फॉर द पैसेंजर्स टू. सो वी ब्रॉट अ रिडक्शन मैकेनिज्म. इट इज अ सिंपल गियर असेंबली जिससे द एयर आउट फ्रॉम बोथ द सिस्टम्स reduces. The air out, the speed of the air out from both the systems, from the secondary cooling turbine and from this system, reduces, and the whole system optimizes. Neither it is very fast nor it is very slow. So this was the whole reduced ambient air cooling system. I hope you got it. This was a very tricky one. There was a lot of explanation. There are a lot of channels and passes. If you didn't get any of the point, kindly let me know. Mail me, type in the comments, or rewatch the whole video. Thank you very much. Do subscribe. Now, wait. The thing is there. Here we'll talk about the pH chart. Here, not the pH chart, the TS diagram. From 1 to 2 dash, it undergoes isentropic compression. Then from 2 to 3 dash, from 1 to 2 dash, isentropic compression for the ramming effect. 2 to 3 dash, it undergoes the isentropic compression in the main compressor. From 3 dash to 4, isobaric heat rejection. From 4 to 5 dash, isentropic expansion. And from 5 dash to 6, it increases the temperature slightly to match the cabin temperature. All processes are analogous to the earlier processes. So now we'll directly talk about the calculations. Mass flow rate of air equals 210 by 60 Q. That brings us kilowatt. This term brings us kilowatt. So we get mass flow rate in kilogram per second. This is Cp into T6 minus T5 dash. As discussed in the earlier video, we use these two terminals only because here is where the heating, or the refrigeration action takes place. In the VCRS system, we used to calculate the refrigeration effect, but in the air refrigeration or the air cooling system, we see that where does the refrigeration action takes place, because in this case there is no refrigeration effects. Like we cannot compare के उसमें heat ले रहे थे refrigerated space से, हम उसको refrigeration effect बोलते थे. इस केस में ऐसा नहीं है. इस केस में our aim is to provide cold air. हमें कहीं से heat लेनी देनी नहीं है. Here is the place where the refrigeration action takes place, and that cold air is sent into the cabin. Got it? Now the W net in the MA into Cp into T3 dash minus T2 dash. There is just one compressor, so these 2 points. I think this is wrong. This should be T3 dash to T2 dash. Not this point. It should be like this. T2 dash to T3 dash. Like we know that T2 dash is equal to T2, but the curve was slightly wrong, so I just redid it, and the point 3 should be here. Yes, now it's good. Like the formula would not have changed because we know that T2 dash equals T2, but the graph was slightly wrong. Now it is perfect. And for COP equals 210 into Q by 60, this comes into kilowatts, and W net was already in kilowatts. So the units are balanced, and hence we get the CUB. Thank you very much.